Hey guys, welcome back. All right, we're going to talk about section 5.3. Now, some of this we've kind of covered, and for some students, period 6, we haven't covered it yet. So, all right. So here we covered this in evil eyebrow. So let's kind of go through my work I sketched out here. It says, is there a relationship between gender and candy? Just like we did a relationship between eyebrow and taco tongue, right? So we look at our data here, and it helps us answer the question given. It says, define A to be the events randomly selecting a student that's male, right? And so I've wrote that here. Then it says B to be the event like Skittles, right? Are these events independent? So the way we figure that out, and here's our notes from the evil eyebrow, is that this formula, if in fact they're independent, all those proportions would be equal. So let's take a look. The probability of A is just the probability of being male. So it looks like out of the 200 people we talked to, 120 are male, right? Now, what's the probability of A given B, right? So given B, so that's given you like Skittles. So these people are dead to me. I'm only interested in the people who like Skittles. So out of the people who like Skittles, how many are male? So it looks like 80 out of the 140 are male. So that's how I got this, right? And then it says, what is the probability of A given not B? So given that you're not B, so given that you don't like Skittles, okay, so these are the people who didn't like Skittles. So given we're talking about those people, what's the probability you're male? So there were 40 out of a total of 60 that don't like Skittles. Now, when we divide these as a fraction, we notice none of them are equal. They're all kind of they all kind of would round close to about 0.6, depending on how you round. So I'm going to say no. No, I have to justify my answer and answer the question. No, people who like Skittles, so that was this people who like Skittles are actually less likely to be male than people who don't like Skittles. Because it looks like people who don't like Skittles, 67% were male versus people that do, 57 were male. Okay? Now, again, just a reminder, you don't have to write out these notes. It's just maybe this would be next to you on your desk while you're referring to those notes. Okay, so let's take a look at the next example. Now, this we covered in the ACEs activity. So again, if you're in period 6, you might want to hold off on this and do it after we do the activity, or feel free to kind of use it as a way to preview. So it says a study of high school juniors come from 3 districts, Lakewood, Sheboygan, and Omaha. We conducted to determine the enrollment trends in each AP math course. Calc or stats? So we've got calc and stats in our table. Okay, so you can kind of think of that as event A. Then it's saying 42% of students in the study came from Lakewood, so 42%, 42 out of 100. And it says 37 came from Sheboygan, so 37 out of 100. And the rest came from Omaha. So with a quick calculation, 100, take away 42, take away 37. We get 21. Okay, now it says in Lakeview, 64% of juniors took stats. Okay, and then the rest took calculus. So you might be tempted to put 64 here and the remainder, 36 here. But notice that doesn't add up to 42. So this is actually a conditional statement. So it's kind of saying of the people in Lakewood, 64% of the 42. And of means multiply. So when we think of that, we want to know what is 64% of 42 and what is the remainder, 36% of 42. And again, of means multiply. So when we take a look at this, and we get Now I notice that I get a decimal, and that's a little troublesome. It's kind of going to throw off my numbers here, but I'm just going to go with it because, again, I'm going to be setting up proportions anyway. So this should be fine. Okay, so I'm going to put 26.88 and 15.12. Okay. Now it says in Sheboygan, 58 of the juniors in Sheboygan and 49 of the juniors in Omaha took stats. Oh, have I got that flip-flopped? Yeah, I think I've got to have that flip-flop. So it's the other way around. Okay. It says in Lakewood, 64% took stats. Okay, so that's got to be this. That's this. Now 58%, so 0.58 of the people in Sheboygan. So there's 37 people in Sheboygan. So 0.58 times 37. All right, and then the rest took calculus. So these would be stats, and this is calc. Stats. And the rest would be calc. And last in Omaha, 49% of the juniors. That'd be 51%. All right, and now we can kind of total those up. So let's figure out how many total stats versus 26.88 plus 21.46 plus 10.29. I get 58.63. Now let's do the same. Okay, and that should add up to 100. I'm just going to double check. Perfect. Now you're thinking, how do you have like a fraction of a person? Notice I could multiply everything by 1. So if I wanted to, I could think of this as 1,512, 2688, 1554, 2146. And then I don't have these fractions of people, right? And that's actually what percent means. It means out of 100, for every 100 people. So this would actually make more sense. You're actually forcing there to be out of 10,000 people, and it's actually a person. Okay, so now it says no juniors took both. So it's mutually exclusive. So there's no overlap. Let's describe this situation using a tree diagram and find the probability that a randomly selected student from the study took stats. So find the probability that a randomly selected person, so a person at random, took stats. Okay, so that would mean the denominator has to be out of my total population. And so then that's simply this 5863. Right? So we know already that that's 58.6% of people took stats if I'm plucking from everyone in the study. So you're like, well, what would how would this have to do with a tree diagram? Okay, so let's take a look. If I'm using my notes here, right? I'm just looking at my notes down here. You're either taking calc or stats. So this is the probability of stats. Let's call our main event stats, and this is not stats or calculus, right? And so this is our event A, and this is not our event A. We can just call that S if we want because it stands for stats. right? Then we have our 2 categories, right? But in our notes, but here, I guess you could take this from these 3 high schools, right? So if we think about it in the way that they went over in the question, I could have sorted it by the high schools and then this. I think it doesn't matter, right? Because I think I actually have calculated all of it. But tree diagram helps us think about these from multiplying. So if I go back and I think about my information chronologically, I can say to myself, okay, I just have students in general, and either you were from Lakeville or Sheboygan or Omaha, right? And so it appears we actually already know that this is 0.42, right? 0.37 and 0.21, right? Now, Lakewood, of the people from Lakewood, it appears as if we have, I don't like this Sheboygan, I'll call it SH. So we have stats and not stats. The stats people were 0.64 and these were 0.36. The stats people from Sheboygan were 0.58 and this is 0.42. Not stats, right? People from Omaha, 0.49 went to stats and 0.51 was not stats. So my tree diagram helps me see that I needed to multiply those. I also showed you why using logic you would have need to multiply those. So we end up getting 0.2688, 0.1512, 0.2146, 0.1554, 0.1029, 0.1071. And so we're thinking to ourselves, would the tree diagram have maybe helped me get here faster? And the answer is yes. Here are all the stats people. And since you can't go to 2 high schools, I should be able to just add these up. So adding these up, these are all the people that took stats. I got 0.26688 plus 0.2146 plus 0.1029. And this would have been a way to do it faster. That's the probability of taking statistics and using all of our ideas of why I'm adding them up. Nice. Okay. So I've proven to you that a tree diagram is technically faster, but it leaves out a lot of logic. But let's consider the same situation we did a minute ago to find a conditional statement. And that's where I find a tree diagram incredibly helpful. So we're trying to find what's the probability the student is from Lakeville given they took stats. So if you think about this as actual humans, what's the probability student is from Lakeville given they took stats? So given they took stats, all these people are dead to me. I can take Lakeville given that they took stats. I could also do here divided by that number. Notice I'm going to get the same fraction. So 2688 right? Divided by 5863. 5863. So let's see what that adds up to. 2688 divided by 5863. Okay. Now, could we have used a formula? And the answer is absolutely. We know using this formula, right, that it's, or we could use the opposite of this. This is probability of A and B is equal to the probability of A times the probability of, I think this is the typo, A given B. Right? So you can use a formula I'm going to divide this on both sides. So I end up getting the probability of A given B is the probability of A and B divided by the probability of A. And this could have been also helpful. So we could have also used that formula to solve for this. Again, we could also use the tree diagram. So it's what is, given that they took stats, so here's all the people that took stats, given that they took stats, what's the probability they're from Lakewood? It's just this one. So it's these 2,688 students out of a total of 5,863 students. Thanks for